Hi everyone, my name is Thomas Kim. Uh, this is my fifth video series, my fifth video for MFC with direct to D. During last session, we learned about Cartesian how to transform Cartesian coordinate system to screen coordinate, and we derived this set of transformation metrics. If you downloaded the sample files, uh, you will find that you will find the 004 transformation theory, the last session, and you can find PowerPoint file, PowerPoint presentation, and two PNG file. If you open it, you can find this kind of bitmaps. So if you haven't watched my previous video, in this session, in this series, you have to watch it to follow with me in this session. Okay, I will copy third, third, my third session, my third session's file, like this MFC extension DLR, and I will rename it in a moment later. I will rename it to OOPIFs, transformation. Let me see. Transformation in code. Okay, I will copy it and I will remove it. You should not change project name in here. If you change, you cannot use it. I will remove two more folders. Okay, I will open this project. Transformation in code. I opened it, and as before, I will in the Solution Explorer, I will change its property to project solution name to something different, like fifth transformation in code. Okay, I will save it and close it, close solution, and once again I will delete it, then I will open again. Okay. Okay, in the class view, D2D here, and double click it. I will add some one struct. I will call it coordinate range. And float. Float will be xn. Xn would be left range on left x range on Cartesian coordinate. Plot x on Cartesian coordinate. Plot y-axis scale on Cartesian coordinate. Okay, then we will add one function here. Void set transform transform and it should be like this. That's it. And we will copy this function once again here. Here we will double click it. It will be in the private sections, and we will implement it here. Okay, and it needs a member function, a member variable private here, coordinate range and range. Okay, I save all. Let's go back here. This and range x n we have to repeat this several times. And xr yd yu xs ys okay. About the scales, I will set defaults here. Up. These are defaults. Okay. Here. These are the files from the previous session. I will add one more member function here. Clear screen. Let's copy it. And move it here. Here. Okay. Okay. Then we can remove it. We can here clear screen. Clear screen. Okay. I don't think we need it. View. Get when the target. Sorry, I think we will need it. CH when P when the target. This MP view get render target. Okay. Now we have to make some code here. Here. Let's see. We are going to use these equations. For your reference, I will put it here. I will close it for the time being. Okay. We need to have width. Width is the width here. So C D2D1 float size F. Okay, size equals P. Oh, we need to render target. CH wind. CH wind render target. P render target. This MP view get render target. Size would be P render target get size. It gives us size. Then float W size width float height size height. Now we have so C D2D 1 D2D1 D2D1 matrix right M we are going to use this equation. W R is here XR XR means this, so XR XN. Okay, M12 M12 is 0, M21 is 0, also 0, M22 H over YD minus YU M31 W XN XR times N. xn. So okay, then I will change it m 32 h over yu yd times yu. Okay, then we need to call set transformation p render target set transform m. Okay, this changes transformation. Okay, then let's go w n minus r times n h u minus d u. Okay, so here again and initialize. Now we call here at the clearing screen, you can say set transform set transform here 300 200 and x I will have a 300. This is coordinate size. Cartesian coordinate size. Y 200 minus 200. Then I will use it default. Okay. Then here we are drawing a rectangle from minus 100. Then we don't need it. We don't need to have size. Then minus 100 0f plus 100 0f. Okay. These are rectangle like this. Let me see. This. Sorry. Okay, here this is set to minus 300. This is set to 300. This is set to 200. This is set to minus 200. And we are drawing a rectangle like this. Back 100 each unit. Okay. So this is coordinate transformation. What it means here, minus 300, minus 200, below is minus 200, negative 200, and positive 200. We are setting coordinate system, Cartesian coordinate system like this, and we are drawing rectangle. This is rectangle, minus back, minus 100, plus 100, minus 100, and plus 100. Okay, let's go. Okay. Here we have to rebuild it. And we missed this function too. I will implement it. We have to define the set transformation here. Set transformation. Here. And this should be deleted. And this is redirection. It should be point. xn, xr, yd, yu, xs, ys. Okay. It simply redirects interface. Then, okay, let's compile it again. Let's build it again. Okay, let's run it. Oh, what's the problem? Some dot. Let's fix some problems, I guess. Initialize x, y, x. Oh, it should be plus. Okay, this is Cartesian coordinate, rectangle in Cartesian coordinate. Rectangle in Cartesian coordinate. So we have to compile it. Okay, let's run it. Oh, what? It's still problems. Left top. Oh, it should be minus. Right bottom. Sorry, I have to compile it again. Okay, it's working now. See this coordinate. Let's see. Here, this coordinate is minus 100 and plus 100. So it should be view minus 100 plus 100. And this one should be, this coordinate is plus 100 minus 100. See, let's compare. You can see minus 1 minus 100 plus 100 minus 100 plus 100 and 100 and minus 100. So these are Cartesian coordinate. Say by specifying in Cartesian coordinate, we can successfully draw graphics on our screen. So this is this transformation matrix, and I want to go one thing further here. That is, let me see in the graphics again. Here I will open Cartesian to PNG. Here, if you watch this equation carefully, we can increase the length, I mean the coordinate system. We can increase if we multiply some factors on n and r, then this axis can magnify or shrink the same way. By using factors, I will multiply here. This is x coordinate, x, s, and we don't need to multiply here because n increases sx, r increases xr, so we don't need to multiply here, but we will multiply here y, s. These are scaling factors, so I will fix like this here, times x, these are scaling factors, and here y, s, let me see, sx, sx, and here ys, y scaling factors. So okay, so let's go once again. We are going to draw two rectangles. No, we will use here, we will shrink 0.05 f, 0.05 f. These shrinks the same rectangle. We have to build it. See, it is still running. I have to build it again. Okay, let's run it. As you can see, it's small. It is small, like this size. I will multiply it here, like 2. Then let's see what happens. Sorry, it's not built. Okay, let's run it. Okay, it's increased, and let's do this. No. These are scaling factors. Run again. You can see the difference. So using these are scaling factors we used here. These are scaling factor. I hope you enjoyed this session very much, and we successfully did Cartesian coordinate, and we derived these metrics in last session, and we implemented it in this session. And this transformation matrix, I mean transformation, Cartesian coordinate, transformation from Cartesian coordinate to screen coordinate, this concept is very important whatever you do with computer graphics. If you are going to do computer graphics in the long run, you have to understand this and you have to know how to implement it. Thanks for watching.